Annualized yields for varying compounding periodicities. Let's see what we mean by this. Let's say there is a bond B1. It pays coupon semi-annually. Let's say its maturity is 4 years. Coupon percentage, let's say, is 10%. Future value is at par, which is 100. Presently, it is trading at 101. Now, we need to find out what is the yield of this bond. Now, if it is paying coupon semi-annually, we can say periodicity or m is equal to 2. Therefore, the number of periods is 4 into 2, which is 8, and the periodic payments is 10 by 2, right, which is equal to 5. Future value is 100, present value is by convention minus 101, so we can easily find out the required return, right? This will be equal to 4.8462, but this is the semi-annual half-yearly yield. To annualize it, we have to multiply it by 2. This is equal to 9.6924. 9.6925 approximately. Okay, so this is coming to be 9.6925. Now let's say instead of being compounded semi-annually, this bond was compounding quarterly. Then what will be the annualized yield? So semi-annual yield we'll give by Y2 and the quarterly yield. Now what if this bond, instead of being compounded semi-annually, was compounded quarterly? Then what will be the annualized yield? Now there is an expression for that. It goes like this: 1 plus ym by m to the power m is equal to 1 plus yn by n to the power n, where m and n are periodicities for otherwise identical bonds. Now let us put up the values here. Now this will translate as 1 plus y2 by 2 square is equal to 1 plus y4 by 4 to the power 4. Now this is the annualized yield for the case where it is semi-annually compounded. Y4 is for the quarterly compounded case, right? Again I'll repeat, Y2 and Y4 are annualized yields for semi-annual compounding and quarterly compounding respectively. These are not the periodic yields, these are the annualized yields for semi-annual compounding and quarterly compounding. So this implies 1 plus 0.096925 by 2 square is equal to 1 plus y4 by 4 to the power 4. This basically means this value, this periodic value. So we just use this 1.048462 square is equal to 1 plus y4 by 4 to the power 4. This implies 1 plus y4 by 4 is equal to 1.099273 We just invert this to the power 4 to 1 by 4 here. Easily we can calculate it. So this is equal to 1.023944. Therefore, y4 becomes 1.023944 minus 1 into 4. This is equal to 0.095777 or 9.5777%. This is our annualized yield when the compounding is quarterly. Now we can also find out what is the annualized yield when the compounding is yearly. How do we do that? 1 plus y2 by 2 square is equal to 1 plus y1 by 1 to the power 1, implying we can take the value from here. 1 plus y1 by 1 is equal to 1.099273, implying y1 is equal to 9.9273%. So when the compounding is annual, the yield comes to be this 9.9273. This is also called the effective annual rate.